This video lecture deals entirely with projectile motion. I'll remind you that a projectile is an object that was thrown or kicked or struck, and it flies through the air in a vertical plane. Last time I showed you the four basic equations, the ones that we will use to solve problems involving projectile motion. Two of them dealt with the x and y coordinates of the projectile, and the other two dealt with the x and y components of the velocity of the moving object. I'll devote this lecture to a study of the x and y components of the velocity. The x component of the future velocity does not change. As time goes by, the horizontal part of the velocity, the x part, x component, is always the same number. Whatever it used to be, it always will be, and always is. And so we express that fact here, that the x component of the future velocity is the x component of the initial velocity. Any future time you have in mind, this equation will be true. Now, the y component of velocity is not constant. It's changing continuously. Through this equation here, the y component of the velocity of an object equals what it used to be when it was first projected, the y component of the initial velocity, minus the amount of velocity subtracted from the initial velocity in the vertical direction, where g is 9.8 meters per second. But in this example and this example only, we will let the value of g be 10, rounded off. It just makes the arithmetic a little easier and makes the lecture go more smoothly, and we get it done sooner rather than later. But make sure you know that this is a temporary change. On an exam or quiz, you make sure to use g as 9.8 meters per second squared. All right, I show the ground, a football on the ground is kicked. Imparted to the football is a vertical component of velocity of 40 meters per second. At the same time, the ball is moving, after it leaves the foot of the kicker, horizontally with an initial horizontal velocity of 30 meters per second. This number in blue, that 30 meters per second, is the x component of the initial velocity. The actual velocity is 50 meters per second this way. You recognize the 3, 4, 5 triangle perhaps. And so these are the components of that velocity vector. So this number is the x component of the initial velocity, and it's 30. This is a number that never changes. This number here always is going to be 30. Let's follow this ball as it travels through the air and lands eventually on the ground. At this location, at time t equal to 0, the horizontal velocity is 30 meters per second. 1 second later, still 30, 30, 30, 30, 30, 30, 30, 30 when it strikes the ground. Have I made the point that the horizontal velocity of a projectile is a constant, and in this case 30? Okay. Now let's talk about the vertical velocity and see how it changes. When the ball leaves the foot of the kicker, it has a vertical component of velocity. Let's say it's 40 meters per second. The height of that arrow corresponds to the 40. With each passing second of travel, 10 meters per second of velocity is subtracted from the velocity. And so at time t equal to 0, you had 40. A second later, you will have lost 10. Now it's 30, then 20, then 10, then 0. So let's count how many seconds. 1, 2, 3. It took 4 seconds for this object to lose all of its upward vertical velocity. It took 4 seconds, in other words, to reach a place where it's no longer traveling upward, not yet moving downward. This location there is the maximum height reached by this kicked football. And we don't, our purpose is here not to calculate what that maximum height is. That's for another example. All right, so we've reached the maximum height, 0 velocity, but Earth is still pulling on this football, subtracting from it 10 meters per second of velocity. So you had 0, a second later the ball is here, moving at 10, negative 10. Then another negative 10 is subtracted, and you get to go from 0 to negative 10, negative 20, negative 30, and when it strikes the ground, just before it touches the ground, its velocity is negative 40 meters per second. The same velocity it had on the way up, but positive. So there's a symmetry in the velocities shown in red. 20 there corresponds to 20 over here. 30 corresponds to 30, or rather to say 10 corresponds to negative 10. And you can see the other correspondences equally well. Well, that concludes what I wanted to say about how the velocities, the components of the velocities change as time goes by. What else could I tell you that's of interest? Well, since we do have time, let's talk about how we might find the maximum height reached by this football. It's important that you know that the behavior in red occurs independently of what's going on horizontally in blue, and vice versa. What you would like to understand, I hope, is the following. That insofar as the vertical motion is concerned, and so insofar as how the velocity in the vertical direction changes, the situation with the projectile's vertical motion is exactly the same as if the football were thrown straight up with a velocity of 40 meters per second. You already learned, or had an opportunity to learn in an earlier lecture, how to deal with objects thrown straight up, or fired straight up, or kicked straight up. So let's ask this question. What is the maximum height reached by the football, the height above ground? Well, the displacement or distance traveled by an object equals its average velocity. We're talking now about one-dimensional motion, vertical motion. It's the average velocity times the time. So let's apply that principle. Distance is average velocity times time to the part of this motion that begins here with 40 meters per second upward and ends with 0 upward velocity. Again, the red data corresponds exactly to the situation where an object is thrown straight up with a velocity of 40 and it ends its travel upward, arriving at maximum height with a velocity of 0. Let's calculate the average red velocity, the average vertical velocity from 40 to 0 using the middle value rule, which is not written on the board. The middle value rule tells you that the average velocity is 1/2 of the sum of the beginning and end velocities. The beginning is 40, the end is 0. Add the 40 into 0 and divide by 2 to get an average vertical velocity of 20 meters per second. Now, how many seconds are we talking about? In this case, it's 1, 2, 3, 4 seconds to reach maximum height. So I repeat for the third time, distance traveled is average velocity, middle value rule, times time. The middle value is 20, the time is 4 seconds, 20 times 4, 80 meters. The height of this projectile, when it reaches its maximum height, is 80 meters. That's enough for now.